Hey guys, today we're going to continue our talk on secants and tangents, and we're going to focus mainly on various different intersections that take place outside of a circle. And there's a few different scenarios here. So this theorem, it's on 743, it states that if two secants, a secant and a tangent, or two tangents, if they intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So what that means, and we're going to go through case by case here. Our first case is if we have two secants like this. What this is saying is the measure of angle A here, that's the angle formed. Well, that's going to be equal to 1/2 the difference of the two intercepted arcs. Well, the two intercepted arcs are DE right up here and BC down here. So it's going to be the difference of the measure of arc DE minus the measure of arc BC. And it will be the larger arc over here, or the smaller arc being subtracted from the larger arc. So this exists if you have two secants like this. Now we'll go through a quick little informal proof of this. How we could show this, this will be our final statement, is we would draw a nice little triangle here, and we have angle A. We'll list the angles we need are down here, angle 1 and angle 2. And what we could say is, well, from the exterior angle theorem in a triangle, we have triangle ACD, this triangle, we would know that the measure of angle 1 is equal to the measure of angle A, that was this red guy here, plus the measure of angle 2. And if we look, angle 1, well, that is an inscribed angle, so its intercepted arc is DE. So we'll list over here in green. We know the measure of angle 1 is equal to 1/2 the measure of arc DE. That is something that we do know. And we also know if you look at angle 2, that is an inscribed angle, so the measure of angle 2 is equal to 1/2 the measure of arc BC. So we do know this from having inscribed angles, and then we could simply substitute in here, move a few things around, and we'll end up right there at the top. If we substitute, we would say 1/2 the measure of DE is equal to the measure of angle A plus 1/2 the measure of arc BC. Then you subtract your measure of arc BC from both sides and factor out your 1/2, and you're going to end up right up here. So there's one scenario. On to our next scenario. Same theorem, just instead of having two secants, this one we'll look into if we have a secant and a tangent. So if we have something like this. If we have, so here's our tangent, it'll be AC, and then we're going to go like this. We'll have B, we'll have D, and this is saying now we have a tangent and a secant. They intersect outside the exterior of the circle here. What this theorem now is saying, same thing exists, the measure of angle A, so still this measure right down here, is going to be equal to 1/2 the difference of, well, the measure of arc DC minus the measure of arc BC. And that's the relationship that exists for this one. And again, we could show this by simply making a nice little triangle, going through the same process actually, very similar to the same process. And we would need angle 1 down here, angle 2. Keep in mind angle 1 is this whole angle. It doesn't stop on the circle. Angles are made by rays, not by a curve like this. So angle 1 is this whole angle. And what we know is, well, we know angle 1 is equal to measure of angle A plus the measure of angle 2 from our exterior angle theorem. And we should know that angle 1, well, this is a theorem we talked about yesterday. We have a secant and a tangent here, so the measure of angle 1, I like the color coding, the measure of angle 1 is equal to 1/2 the measure of DC here. And then the measure of angle 2, well, that's just an inscribed angle, so we should know that from a while ago, before spring break, that it would be 1/2 the measure of BC. And then we can do similar to what we did before, substitute in for the measure of angle 1 with what we have up here, substitute in for the measure of angle 2 with what we have here, subtract from both sides, factor out your 1/2, and you'll end up here as well. So this exists as well. This arc CD minus BC, take 1/2 of that, that's the measure of angle A. That's our second scenario here. And our third scenario is, instead of having two secants, or a secant and a tangent, would be if we have two tangents. So two tangents would look like this. There's one tangent. There's two tangents. So it would be like A, B, C, and we'll throw a point D here. And what this is saying, if we take angle A, the measure of angle A is going to be 1/2 the difference of, well, the measure of arc, and now we want it to be the major arc, so BDC minus the minor arc there, minus arc BC. And again, we can show this simply through a very similar type of thinking here. We can make a little secant, draw a chord in there, and then we would need angle, call angle 2 up here, angle 1 down here. The measure of angle 1 would be equal to, well, through the exterior angle theorem, the measure of angle A plus the measure of angle 2, that would equal the measure of angle 1. And the measure of angle 1 from the theorem we talked about yesterday, we have a secant and a tangent, they're intersecting on the circle, so that means the measure of angle 1 would be 1/2 the measure of, well, the arc BDC. And then if we look at angle 2, well, that also is a secant and a tangent intersecting on the circle, so the measure of angle 2 would be 1/2 our measure of arc BC. That is an arc. And then we could simply substitute, subtract, factor out the 1/2 again, and we'll still end up here. So these are the three relationships now if we have an intersection outside of a circle, of tangents and secants, different combinations of those. Now, before you start trying some of these on your own, what really might help kind of bring this all together, if you go over to page 745, there's this really useful table, and it breaks it into 3 categories. And these are all about different angles that are formed with intersections of secants and or tangents and combinations of them. So in your top row up there, it's just your different scenarios where you could have an intersection on the circle. So intersection on a circle, that would be like two secants intersecting like this, and we have a 1 and an x degrees, or you can intersect on a circle with a secant and a tangent like this, and that whole angle is angle 1 and x degrees. And if you're intersecting with either two secants or a secant and a tangent on the circle, the relationship is always that angle is equal to 1/2 the measurement of the arc that is intercepted. So the measure of angle 1 here and here is going to be 1/2 of the arc that it intercepts. Simple enough. That would be if you're on the circle. And your other scenario we talked about yesterday, if you have two secants, and now it's just secants, because you're intersecting inside the circle. So if you're inside the circle, call this angle 1, call this, I think they call it y and x. So if you're inside the circle with two secants, the measure of that angle, angle 1, is equal to 1/2, and then it's going to be the sum of the angle it intercepts, so that would be y, and the sum of the angle that its vertical angle intercepts, so it's 1/2 x plus y. That would be the measure of angle 1 here. And our last scenario, we just talked about all 3 of them today, and I'll write them down just because. So our 3 were if you intersect on the outside, two secants like this. I'm going to call that angle 1 in here. This will be x. You could intersect with a secant and a tangent, but still outside. So angle 1, this would be your x and your y. Oh, I forgot y over here. Kind of hard to see. This is angle 1 inside, this is y for the arc. And your last one would be if you had two tangents. That is supposed to be tangent. Now it is. So angle 1, and then we'll call it x outside for that major arc and y for the minor arc. And then your relationship would be measure of angle 1 equals 1/2, and then it's the difference of that larger arc subtracted by that smaller arc. So that table kind of helps organize everything in different scenarios you might see. It's just about knowing when to use which relationship. All right, so you can go ahead and try some of these on your own. Have a nice day.